So the talk about today is implementing your own Smalltalk dialect, and I would not go into technical details. If people want, they can come later. It's more about the process of starting and doing a project. And there will be some technical stuff. Come after the talk, we can talk about it. It's more about the experience of doing the project. So before you start such a project, you have to ask yourself, why are you doing this? This is a new Smalltalk dialect. So what is the goal? Stefan mentioned a vision. I will use the word goal for it. For me, this was learning how to couple with a complex project, how to break this thing down, to improve my skills, obviously, challenge my brain. I like challenges, obviously. Create something useful. And, of course, have fun. So you need to define the scope of the project. Without scope and without clear goals, you will never finish your project. Because you don't know where the finish line is. And even if you don't write it down, like on a piece of paper, you still need to have those goals. They must exist somewhere in your head. So the goal of the Iron Smalltalk project is to create a new Smalltalk dialect. We want a clean implementation, reference implementation. That means something that conforms to the Smalltalk project, to a Smalltalk standard. And in this case, it's the NCX3J20 standard. We want it purely on the .NET dynamic language runtime. We want it to integrate with the .NET. We want, very important thing, we want the thing to be production quality, which means it should be stable, it should be robust, it should be easy to use, it should be documented, and one very important thing, it should be maintainable, because new features come, so you need at one point to do something about it. One very important thing to figure out is what's not in the scope. This is also very important. In this case, in version 1 at least, it's not to have a GUI framework, it's not to have an extended class library, and it's not to have extensive performance optimizations. You can always do this later. You have to have it running stably. So let's start with the thing. The first thing to do is get the reference documentation. The Smalltalk standard, there it is. Print it out. I like piece of paper because on piece of paper you can take notes. Get the .NET DLL documentation. Print it out. There it is. Read it. Not just print it. Read it. Structural breakdown. Break it down structurally into areas you're going to work on. So the Smalltalk part is the Smalltalk language, which I call the runtime. The Smalltalk interchange format, which is the file in and file out format, and the standard class library. So this is the three things we need to implement to get a Smalltalk running. And the first part, the Smalltalk language, which is the most diffuse one, it has to be broken down into three subcategories. One is the Smalltalk abstract program grammar. The other one is the method grammar. And the third one is the lexical grammar. In other words, this is the behavior and classes and other stuff. Some parser that can parse with the methods, and some scanner that can get text to some kind of objects. So with every other thing, we need a hello world. And it will be transcript show fast 2013. So the first thing to do is write a scanner. You need to transform this piece of text to something useful. And scanner takes the text and outputs some tokens. The important part here is the tokens have type of different types, and the other important part is that the token has an indication where in the source code it came from. This is useful when you get problems later, like something's gone wrong, so you can find out what went wrong. So every chapter in the lexical grammar in the Smalltalk standard becomes one subclass of the token. And for example, 353, which is called identifier, is identifier token. 356 numbers is a number token. The source code 123 becomes a small integer token. This large integer becomes a large integer token. Well, in .NET, turns out there is already a class. It's called big integer. That's why we call it big integer token. So just to use their convention. This is a scale decimal. and if there's a big integer, we need a big decimal. Turns out they don't have a big decimal. Big integer in .NET is infinite integer, similar to the Smalltalk integer. Use it if it's there. Why invent it your own? Big decimal, there is not such a thing. So we have to create our own big decimal. And there come strange things. So you define a scale decimal 1 with precision of 2, divided by 3, multiplied by 3. And what is the result of this? The standard doesn't say, unfortunately. At least the way I read it, I couldn't find a definite answer. So some Smalltalk says this is 1. Some other Smalltalk says this is 0.99 because the precision we asked is 2 decimals. So I had to decide. I decided the second one because it was easiest to implement. And because this is ambiguity in X3J20, you need to document it. This is another thing that's ambiguity in the standard. So the standard allows you to have binary selectors of infinite size. So in this case, I have this imaginative method called plus plus. It's not like the normal plus plus, but this takes the first operand and plus is the second 2 times. So in this case, 40. So you see the tokens that you get out of it. So what happens is if you get the minus minus token there. So you would expect this to be binary selector minus minus. Unfortunately, the way most other Smalltalks works is it's not minus minus, it's a negative sign for the 2 following it. So why does this have precedence? We don't know. The standard actually doesn't say. So I decided follow what the other Smalltalks do. So and even worse is even if there is a white space after the minus, it's still part of the integer. So this is something you have to document the way it works. So tokens have preference sometimes, unfortunately. You can't just scan from left to right. And one of the things I discovered is the negative sign is a tricky thing to handle, so you have to check what's coming after it. Oh, it's a minus, but it's not an integer, so we have to put the token back as negative sign and want something else. Vertical bar has several meanings. It can be the separator for temporary variables, or binary selector, and we have some issues with array. So we have to extend the standard sometimes. For example, the standard says this is how you define a literal array. Turns out this is also a way to define it, but it's not in the standard. And most people, they'll be crazy if they have to write the hash every time inside. So extend it, document the extensions. Write unit tests. Unit tests are not easy to write, by the way. Feed it garbage. This should not crash the thing. It should be robust. It may not crash. Returning invalid tokens is acceptable because you might use this scanner, this compiler for code completion and other stuff where the code is not complete. Unit tests are difficult to write. Test up is what I ended up writing, where I can type stuff on the fly and see what comes out of it. It should hopefully not crash. And you see this says like the string token is missing closing quote character. So now we have a scanner at least. The next thing is to write the parser. The parser takes the interesting tokens, so the white space are not interesting, and tries to create abstract AST out of it. I don't know how to pronounce it. And it has rules how to handle those tokens. And the thing is, I don't have to explain this. You know it already. There is the abstract syntax tree. It has reference to the tokens where they come from. Write unit test. Feed it garbage. It has to be robust. It may not crash. And return it invalid or incomplete nodes is acceptable in this case. At later point, you can say this cannot compile to a method, but at least the parser should not crash. And write a test app to exercise this. This is what I did, at least so I can inspect that my stuff is working. So now we have 2 components here running. The next thing to do is you figure out, right now, technically you could write an interpreter on top of this abstract syntax tree and have Smalltalk running. But since we're doing DLR, we have to go a little bit into the dynamic language runtime and figure out how that works. So read, again, I like to use the marker of what is important, not write notes in the margin. Obviously, hello world from DLR. And it will be very simple hello world. Compiles our dynamic code that returns the string hello world. And I'll not go into details. This is C# code. But basically, they have a abstract tree of expressions which does this. There is an expression called constant, which has a hello world. There is an expression called lambda. Lambda roughly compares to a block, something that you can evaluate. And this would be the Smalltalk counterpart. Lambda can be compiled to a function pointer. And function pointer can be executed. So you call the function and it returns your hello world. We are happy. That was easy. So the tricky part now is, well, the important part is the DLL expressions. Those are the key to everything. So the tricky part now is to take the Smalltalk syntax tree and convert it to a DLR tree. And for that we need an expression compiler. This is at least what I call it. So this depends. Yep.
Can you go back?
I'm trying.
Okay, you say that with the syntax you can write an interpreter.
Yeah.
But what you are missing the stack element of the context. If you want to write an interpreter, you have, for example, how to manage filters in blocks. So this means that you need something else than this IST.
Yeah, but the interpreter, if the interpreter is big enough, it will have the context, etc. The thing is, we're not going that way. We're going a different way, and that's why it's not part of my presentation. We'll have to compile natively, so I'll actually talk a little bit about exactly this thing. So dependency on Smalltalk definition. So we need now, you see there is a thing called transcript. So that variable have to be somehow handled, variable reference. So at that point of time, you have to define what the Smalltalk runtime is, which is the image. So bindings, this is where the variable lives, like they are called associations technically, but the term is bindings for global variables, for pools, pool variables, instance variables, etc. So and this is actually the tree that we'll look at, and we'll have to. Oh, anyway. Those things we'll have to fix to do the dynamic call and variable reference to get our hello world example to work. Dynamic call side binder, which I did a presentation 2 years ago, I'm not going to this, is what does the polymorphic sense. So that have to be implemented into the runtime. We need some behavior for the methods. We need compiled methods. That was quite tricky to define what the compiled method is in my Smalltalk. It took very, very long time. We need the symbol table, so symbols. Symbols turn out to be not very useful in this Smalltalk. They are used very rarely, to be honest. Because once you compile it into native code and you have your polymorphic cache working correctly, you don't need them. They only need for a few lookups here and there. So we put the runtime component and we put the expression compiler component. Then we have to think a little bit about challenges. So one of them is instance variables. How do we handle this? Well, the way I did it is I have an object, because all the objects actually have to be written in .NET, and you don't have, for example, objects have a predefined size. So the way it's done is it has a slot called instance variable, and the instance variable are kept inside an array. That could be optimized later. Block closures were one of the biggest problems. So because there are two things. First of all is access to variables. So in this simple example, we have temp1 and temp2. And temp2 is used inside the block. And the block can outlive the lifetime of this method, the invocation of the method. So classical Smalltalk uses context objects. Optimized Smalltalks allocate temps on the stack. This is what the coq VM does. Some variables still need a context object. So the trick is to figure out which variables goes on the stack and which needs to go on the heap in a context object. And this context object can be an array or anything. Array is the simplest thing. So turn out the DLL does that automatically. It was nothing to write there, not one single line. The other problem is the return from blocks. This is where you need the other context. So this was more tricky. Normally, this is a stack with invocations. You return to the method that called you. Sometimes the block needs to return from the block to the caller of your method. So the block was defined in my method. And this is not the normal return way. This is actually an exception. And this is actually the key to the way to solve this in .NET. You use exceptions to return somewhere else. And basically what you do is, in your method, if there is a block, you put an exception handler around it. Inside the block, instead of returning, you throw the exception, and you catch the exception and return the value. The exception can pass the value with it. So that's the way you bypass it. Even if there is the way it bypasses. If there's an exception handler in the middle there, it might catch your exception, which is a problem. So it can prohibit return from the block. .NET, luckily for us, allows any type of object to be thrown, not only exceptions. Come on. And catching non-exceptions in .NET is not easy, and therefore unlikely to happen. So that's good for us. And Smalltalk actually allows us to stop the return. This is what the ifCurtailed method does. You can actually catch this block return and handle it. So this is okay. If people want to do this and they insist on doing this, they can do it. It's allowed in Smalltalk. So even if there is external code in the middle, which is like code to APIs and other stuff, this model will work because it's handled by exception mechanism. Primitive blocks are inlined, like if true, if false, while, etc. There's no way around it. So next thing is to do the variable reference for transcript. We need to define the globals and pools, etc. For that, we need a thing called definition installer. So we create a definition of a global named transcript. The standard says there are certain rules that it needs to pass. So we validate, and if it's okay, we install it into the image, which I call the runtime. Same is true with classes, with methods. Methods gets a pass tree as an input. But the thing is, we don't do it one by one. We have a thing, definition installer context, where we give all the definition in it. We call validate, and if it passes, we install. So everything happens in one single operation. The order of definition is irrelevant, because it doesn't really matter how you put them into the context, it knows. There's one thing that's important. This is the initializers. So the order of initializers is important. It cannot sort the initializers on its own. So now we have a definition installer. So how do we drive this definition installer? Obviously, it's the Smalltalk interchange format, fileInts. So I don't want to talk about it. It's basically defined in the standard fileInt file. You define the stuff. You need a parser for this. You write the parser. You visit each parse node, and out of this, you create definition nodes. So, for example, global constant transcript creates a global constant named transcript, which it adds to the installer context. Simple. It should be able to handle several input source files at once, but the order of the source files is important because it dictates the order of the initializers in those source files. So we have the interchange installer. We are almost ready. We need to do the dynamic calls now, so the methods that we need to handle. So for that, we need a class library. So again, the standard, print it out. It has a definition of how to do the class library. But it's big, so we need to automate. Stefan mentioned this. Don't do things by hand. So you write a script to convert the PDF file to a structured XML file. So this is a definition of the isnil message. It says what it's supposed to do. We convert it to XML. And for that, we need a tool to read and write the XML, because tools are nice. They can verify stuff for us. So I decided to write a class library browser. All this, by the way, most of this is written so far in .NET. And I wrote this tool, which looks like a primitive class library browser. It shows the protocols. I'm not going to talk what a protocol is, but it's the messages that certain class needs to implement. Class hierarchies, definition of classes, methods, etc. And it shows you what it's supposed to do, the implementation, some other stuff. The important thing is the validation. So the XML, the standard says this particular protocol should be implemented by a subclass. This particular class should implement this in these protocols. So in this case, I have some primitive validation says, whoa, there's nobody implementing the transcript protocol. So I still need to work on this. So kind of know what I've done and what I'm missing. And it's an internal tool, so I figure out decide to code it simple, ugly, hack way. Big mistake. Never take shortcuts. I mean, it's going to kill you at one point. So 2 weeks later, I scrapped the whole thing. That's not the way to go. Use some proven patterns technologies. Even if you think like, it's a small thing, it's an internal thing. The code in this thing is spaghetti and poorly maintainable. And I said, never say it's for internal usability. Never say I will take shortcuts. It's gonna kill you at the end. Do things properly. It's 2 or 3 months work of GUI plumbing. I hate this. This is just waste of time for nothing. A tool that's only gonna be used once to bootstrap the Smalltalk. But that's the thing you have to do once in a while. So now we have the class library, and the thing is getting more and more complete. You need to implement the show method. So I'll go into details a little bit about this. So in this case, will be transcript show a string. So transcript in this world is a console, so the command line console. And the show method is called write in .NET, so you can write to the console. And we need to extend the standard with primitives. So we defined our own primitive syntax, which is hopefully very similar to other Smalltalk syntax, like static, which is a static method, and the class, which contains the .NET class, which contains the method, write, and some string. String is the type of parameters that's sent back and forth. And this needs, at this point, the components were kind of ready, but you need to go back and refactor some stuff. So you go back and change the compiler to support primitives, change the expression compiler to compile the correct code for those primitives. And most of the work is in the expression compiler. And this type of things takes a lot of refactoring, especially for the primitives. So it's an extension to the X3J20. It needs to be documented. It's your own stuff. And now the thing is mostly completed. We should be able to run our example. And the modules are mostly completed. But we need a way to drive this stuff. Let me go back. So all those stuff except the class library is written in .NET. And they are DLL files. So there's no exe, there's nothing else. Those are modules, those are components that you can use somewhere else. So we need a way to drive the interchange installer. And the way to do this is to have a console host. Let me just take one. Console host is the first thing that you can actually execute. It's an exe file that can execute Smalltalk code files. It's a very simple and trivial component. It reads the command line and feeds the interchange installer with the name of the file. That's it. And you're ready to run your Hello World app. So you run it, est-exe, hello world, and it says undefined. And you start like, all right, there is a problem somewhere, obviously. So you look at your code, and this is very easy. I mean, obviously you misspelled transcript. But it's not user-friendly. So you go back and modify the modules to tell you what's wrong, not just undefined, but what's undefined. So you run it again, and it crashes with Stack Overflow. So at least it compiles now correctly, but something is bad. So you start debugging, and this is where it gets tricky. So it says there in the Visual Studio debugger, the core stack, lightweight function, lightweight function, lightweight function, which means Smalltalk functions, but you don't have idea what they are not debuggable, nothing. This kills you. So you can start guessing. That's not the way to do it. So it's impossible to debug. You read the documentation, how to handle this. Documentation has nothing on this topic. You get desperate. Iron Python and Iron Ruby show the stack traces. We don't. So what's wrong with us? So you rewrite the console host to integrate with the DLR. You hope this is going to work. It doesn't. 1 month of wasted work. You dig more into the Iron Python source code. And DLL has a helper method to compile lambdas with debug symbols. Aha. So it says there, blah, 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 blah. Dynamic methods cannot have debugging information. Ow. and you're compiling dynamically. So obviously, debug symbols are the key, but you need to work around this limitation. So you need to compile the dynamic code to a method, not a dynamic method which only exists in memory. But the compilation happens deep inside the DLR, and you decide to hack this this part of the code. Wrong way. 2 weeks wins it. This is not how to go. You go back and look at the DLR code. You experiment. It becomes more clear because you didn't fully understand what a code side binder is and the concept behind it. You need to split some logic of the code where you, for example, the transcript show method code, you kind of, this is very technical, but the first part is the polymorphic test, is save this transcript, then execute this code, else go back and look up where to do the show stuff. So you need to split the console write line implementation for the transcript show method out in its own separate method and have the polymorphic part relatively simple. Self is transcript, code at implementation. If not, go back and do some more lookup. So compile the Smalltalk methods to native methods is the solution, which for what you need? A native compiler. So it compiles DLLs or exe files from Iron Smalltalk code. Compiles native methods from the output of the expression compiler. And also does some initialization stuff of the runtime. So it fills basically the Smalltalk dictionary with the stuff that needs to be there. So now we have the native compiler on top of it. And the picture is getting more and more complete. It compiles dynamic code to a method. Now, compiling dynamic code to a method hits some limitations. So some things have to be worked around. So you cannot put live object inside the literal array and compile it to a native code. You can do this with dynamic methods, but not with methods that are stored on disk. So you need a different strategy for this. And you need basically to embed, you cannot embed references to object directly. You need to do some lookup indirectly and cache those. For example, symbols have to be created on the fly from strings, etc. So for that, you extend the extension compiler with a compilation strategy. You have to do some refactoring there and there. Huge refactoring, actually 6 months of work, finished a month ago, and I have to be tested this work. So the lesson here is refactoring has to be done, and it will cost sometimes, but it's the only way to go. But there is a bonus as well. So breakpoints come for free, because once this is working, it outputs PDB files, so you can just open the file in Visual Studio, click on the breakpoint, and it breaks, because it's built into the Windows infrastructure. Debugger stepping comes for free, so you can step into methods if you get stuff correctly. And at this point of time, because I'm running out of time, I'll do a very short demo of the Hello World app. If I can exit this thing. Does it come there? Yeah. I hope it's big enough so it's visible. We'll do it very, very simply. Initializer. I hope it's spelled correctly, otherwise we'll have to fix some bugs. All right, Iron Smalltalk compiler, hello world, and it outputs an exe file. Yeah, go ahead.
So, can you show me the component stuff?
The what?
The slide with the components.
Maybe. Can I answer that in a second or now? This one?
Oh, but wait, finish first and...
Right, I'm almost at the finish, so I'll... So, are we going forward or backward? Right. So, lessons learned. It takes time, a lot of time. It's a hobby project, so a lot of time is available. Girlfriends interfere with this type of projects. So, why are you working on this? You don't get paid for it. So, relationship ends. More time for small talk. So, but the important points are stick to quality, try to test and document. Unit tests are not easy, at least not for me, but try to do them. I prefer quality code that validates assumptions. What does that mean? For example, if you have a method and you accept a class, validate that they don't give you garbage. So nil is not good for the smalltalk class. It has to be given. And throw an exception already there. I'm getting old and start to forget things. So document what it does. And there's some method that does something. Put some documents. So this is the C# semantics of what is doing below. Have a plan. What Stefan calls a vision. What to develop and when. Find a sparring partner, somebody you can talk to. That is very good if you can. To discuss ideas. This is the current state of the project, roughly. Doesn't mean it is tested, but it means where it's developed. So the class library needs some work, and the runtime and expression compiler. Finish it. Finish it. I know it's a research project, but if you don't finish it, it's not going to be a successful project.
How do you know when it's finished?
That's what one of the first slides was. You have to need a clear goals and scope of the project.
I know, but there must be some.
When the standard is implemented, it's finished.
Okay.
Then comes version 2.
Okay.
But version 1 is finished.
Okay.
So what we're missing is integration with .NET generics. Implement event model to that interacts with the .NET. Full .NET integration. Write user documentation and tutorials. Get it out to people. And then think of the next version.
Our next relationship.
Yes, I have a question.
Yeah, I'll get to the slides. So, what?
You see, for example,
Yeah.
just because I want to understand the compiler. So you wrote the compiler in C#.
Yeah.
Why? So this means that now, if you want to have your compiler at the level of Iron Smalltalk, it's a black box. So why you didn't decide to write your compiler in Smalltalk that will output C# code like that? Once your stuff runs, you just reload your compiler and boom. So this means that you have all the code for you and all the logic is in the second. You just use another Smalltalk as the bootstrap.
But first of all, because there are two. Yeah, I could have used another Smalltalk to bootstrap it, but the thing is, to bootstrap the stuff, you need to interact with .NET, and you don't have currently Smalltalks that interact with .NET very well.
Generate code.
That could be. The other part was that part of my goal was to learn how to implement a standard, including writing the compiler out of the specification.
Yeah, but what I mean is that you can do exactly the same process, but you use your Smalltalk now, and then at the end you say, oh, now I can bootstrap.
True. The problem is, and this is a personal thing, at work I use a thing called Visual Smalltalk for a customer, because the customers I work for. But from some Syncom licensing restrictions, I cannot use this for private projects. So I cannot use this particular Smalltalk, which I know. And I'm not sufficient enough in Faro and other Smalltalks to do this. So that was the reason. So, yeah. If you have questions, you can ask now. Otherwise, I'm around. So, thank you.